Yeah, good evening, viewers. Welcome to my channel, Mathematics Medicine. Alright, so in today's video, we are looking into special functions, but to be precise, we are dealing with the gamma function in today's video. So if you're new to this channel, please don't forget to subscribe to my channel, like my videos, comment, and also share. Alright, guys, let's dive into work. I'm sure you guys are very like the factorials very well. Factorials of numbers, you know how to find factorials of numbers very well. Like let's say you're asked to find 0 factorial, which is 1. We all know that. 1 factorial, which is 1 multiplied by 1, which is also 1. You have a 2 factorial, which is 2 multiplied by 1. Then you have 3 factorials, which is 3 multiplied by 2 multiplied by 1, which is 6. You have 4 factorials, 4 multiplied by 3 multiplied by 2 multiplied by 1, which is 24. Like 5 factorials, that will be 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, which is 120, and the likes. And then like n factorial, so that's gonna give you n multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3 dot multiplied by 3 multiplied by 2 multiplied by 1. That's factorial. I know you understand factorials very well. You're not new to factorials, but I want to ask you guys a question. What if I ask you that what is the value of 1 over 2 factorial? You'll be wondering, because let me ask you this: does factorial exist for non-integers? Answer the question. Does factorial exist for non-integers? Yes, surprisingly, yes, it does. All right, so factorial exists for non-integers. All right, and then the answer to this beautiful question is also beautiful. It involves one of the most beautiful integrals in mathematics, very unique and beautiful. Okay, so that is 1 over 2 factorial will result to square root of pi over 2. Very unique, beautiful, and famous result in mathematics. Factorial is only defined naturally for positive integers. I hope you know that. But how do we extend factorials continuously? Answer the question, how do we extend factorials continuously? Mathematicians search for a smooth extension that leads to what we are here for today, which is the gamma function. Very beautiful, gamma function. And which says that, gamma of n equals integral from 0 to infinity of x raised to the power of n minus 1 exponential negative x dx. Very beautiful, very beautiful. And then take notes, gamma of n equals n minus 1 factorial. Very beautiful, very beautiful. And take notes, this improper integral converges. Take note of that. It converges and it works for many real and complex numbers. And also take note of this, gamma of n plus 1 equal to n factorial. Is it not concerning? N factorial. This is concerning. There's a big connection between the gamma function and factorials. There's a big connection between them. You're gonna love this. Very beautiful. You're gonna love this. I hope you are getting it. You are jotting something down. As you're watching, please don't forget to subscribe, don't forget to like, don't forget to share with your friends that also need this particular topic that we are treating today. Now let's test for some integers n. Let's start with gamma of 1. So let's say you want to find gamma of 1. This will be equal to integral from 0 to infinity of x raised to the power of 1 minus 1 exponential negative x dx. And this is going to give you integral from 0 to infinity exponential negative x dx. Then if you integrate exponential negative x, so definitely that is going to give you negative exponential negative x. Then you apply your limits 0 to infinity. So this will be equal to, negative exponential negative infinity, then minus negative, if you input 0, that will be 0. Then I remember exponential negative infinity will give 0. Then minus 0 is still 0. So you have 0, then minus this minus will give me plus, and exponential 0 will give me 1. So definitely 0 plus 1 will give me 1. So therefore, we have gamma of 1 to be equal to 1. Very beautiful, isn't it? Very beautiful. What if you have gamma of 2? Gamma of 2 will be equal to the integral from 0 to infinity x raised to the power of 2 minus 1 exponential negative x dx. So definitely this will give us integral from 0 to infinity x exponential negative x dx. So here you can make use of your integration by parts and the solve and the get your answer. But not to waste my time, you can watch my videos on integration by parts. Then when you do that and you apply your limit, so definitely you should go 1. Isn't it? You should go 1, because if you apply the formula I gave you, I said gamma of n equals n minus 1 factorial. So gamma of 2, that will be 2 minus 1 factorial, which is 1 factorial, and 1 factorial is equal to 1. We can say gamma function is very connected to the factorial. But what we need today is 1 over 2 factorial. Don't forget that. You want to find 1 over 2 factorial. But before that, let's say you want to find the gamma function of half. How do we do that? Gamma function of half. So this will be equal to, if you apply the formula, integral from 0 to infinity x raised to the power of 1 over 2, then minus 1, then exponential negative x dx. Okay, so moving on. Let's use another marker. So this will be equal to integral from 0 to infinity x raised to the power of negative half exponential negative x dx. So what are we going to do? We're going to make a substitution. So we can say put x to be equal to t to the second power. So we have the x is equal to 2 t the t. So we have gamma of half equals, integral from 0 to infinity, because the limit is not changing. If you put t to be infinity, you have infinity, and if you put t to be 0, you have 0. Then x is now t to the second power, you have t to the second power, then raised to the power of negative 1 over 2, and then you have exponential negative x, that will be exponential negative t to the second power. Then the x is now 2t the t. Very beautiful. So we can bring out these two. Then if we do that, we have 2 multiplied by integral from 0 to infinity. Then here 2 comes to 2. Then you have 2 raised to the power of negative 1. Then multiplied by t, multiplied by exponential negative t to the second power, the t. Then you have 2 multiplied by integral from 0 to infinity, e raised to the power of negative t squared, the t. Let me recall this for you guys. So if we have integral from negative a to a, then I have f of x dx. So this is equal to 2 multiplied by integral from 0 to a, then of f of x dx. So definitely we can transform this into this form. All right, so we can say that gamma of 1 over 2 equals, integral from negative infinity to positive infinity, because your area is infinity. So you have exponential negative t squared the t. All right, take note of that. But recall the Gaussian integral. That's the a very famous integral in calculus. Okay, the Gaussian integral, which says integral from negative infinity to positive infinity exponential negative x to the second power dx is equal to square root of pi. So definitely this result to square root of pi. Very beautiful. That is gamma of half result to square root of pi. But that's not what we want to find for today. Remember, we need 1 over 2 factorial. But take note of something. Take note of something. I said gamma of n plus 1 is equal to n factorial. So that shows that in this case, if your n is half, so definitely 1 over 2 factorial will be equal to gamma of 1 over 2 plus 1 altogether. And then also recall this. Gamma of n plus 1 is equal to n multiplied by gamma of n. So definitely I can say this is equal to 1 over 2 multiplied by gamma of 1 over 2. And we already have the value of gamma of 1 over 2, which is square root of pi. So definitely 1 over 2 factorial is equal to 1 over 2 multiplied by square root of pi. Very beautiful. Very beautiful. And that is the answer to the problem. Okay. So, gamma function is very important in probability distribution, in quantum physics, in statistics, in engineering, in machine learning, in differential equations and the likes. Very useful topic. Okay, so in my next video I'm going to talk more about gamma function. All right, so if you like this kind of video, please don't forget to subscribe to my channel. Don't forget to like my videos. Don't forget to share to your friends that also have interest in learning this beautiful concept. All right, guys, so thanks for watching. See you next time. Goodbye.